All right, how's it going, everybody? Today we are going to continue to talk about notes 3.6, where we're going to continue to write the equation of polynomial functions. But in order to do that, we're going to go into a little more detail here for the honors class. And so we're going to continue notes 3.6 here. So now it says, recall writing an equation in intercept form given the x-intercepts and the y-intercept. Intercept form obviously looks like this. Now remember, when they say intercept form, that's just another way of saying that it's already been factored for us. So this is factored form. Notice we see it here. When we're looking at intercept form, though, we're going to be plugging in for three values. First of all, it's the a value that determines whether our polynomial is opening up or opening down, especially for a quadratic. And then, of course, we're going to be filling out two spots. We have the letter P, which represents an x-intercept, and then our letter Q, which also represents yet another x-intercept. Notice how the minus sign needs to be there. So yes, your P and your Q are your x-intercepts. All right. Now, when we're looking at this, it says write an equation of the parabola in intercept form. So when we're looking at the information they gave me, they said your x-intercepts are -4 and +2. Well, technically, they have now given me my P and my Q. So we have our x-intercepts. But then they said my parabola, right? It's still a polynomial, but this parabola is going to be going through the point 0, -2. So let's zoom it in nice and big there. Now, this is a y-intercept because the x value is a 0, and we have our y value of -2 as well. Doesn't mean that's the vertex or anything, but that's okay. We just need any random point our polynomial goes through. So looking at my function, right, when we were looking at it up here for intercept form, then I'm going to set it up and plug in the information where it belongs, at least the information we have for now. So it says y equals, I'll just write that instead of f of x for now. Y is equal to, now I have no idea what the a is, so I'll write that in. Then I'm going to write x minus, I do know the p value is -4. And I'm going to write x minus, notice it's always a minus sign, and then my q, which is 2. And I understand we have a double negative. Well, now we can feel free to change it to a positive. So the only thing missing in my equation is I just need that a value. The a value is the only thing that I need to find, and then I'll be done with this problem. Only thing that I was missing to write this equation. So in order for us to find the actual equation, then I'm going to take a moment to find what a represents. And in order for me to do that, I'm still going to use this equation, but don't forget, we know what y equals. Y is equal to -2, so let's plug it in. This is where we now plug in everything we know, except for the a. It's the only thing, I still have no idea what it is. Our x value is 0, so it's just 0 plus 4. Our x value is still 0, so it's just 0 minus 2. So it's kind of nice when they give you a y-intercept. The problems become a little bit easier for us. Again, our goal is to find out what that a is. So once we do that, we're going to do a little multiplication. And of course, if you need to use a calculator, feel free to do so. So we have 0 plus 4 is still just a 4. We're still trying to find that a. So this is a 4. This is a -2. You multiply all three of these together. So -4 is equal to 4 times 2 is -8 with the a right next to it, of course. Again, don't forget, we're trying to find what that a is. Once I find it, I'm going to throw it back up here and I'll be done with this equation. And so divide by -8. And of course, we always reduce our fractions. We can't leave it as a negative over a negative. It's now a positive. The 4 and the 8 should also be reduced. So that reduces to a 1/2. So there's my a value. So that was our goal. We were trying to find what that a value is, because now I can actually finish writing the equation of this parabola, still a polynomial, of course. So I'm going to come back where I left off. I'm going to bring it back. And now they said y equals, right? We're writing the equation. That's what they wanted. My a value, the only thing that was missing, I now have it is 1/2. And then I just copy the rest. I'll just write x plus 4 this time, and then x minus 2. And just like that, we have the equation of a parabola that has these two x-intercepts, and it goes through this point. That's all we have to do for these types of problems. We're writing the equation based on the information that is given to us. So let's try one more time. You should be trying this one, but we'll do it together. Just see how you do with it. So it says, given the x-intercepts. All right, so we have some x-intercepts again. My x-intercepts are -5 and +2. There's the P, there's the Q. So now we're ready to get started here. We already know this is x and y, but that'll come in later. We're going to get our equation ready first. So it's y is equal to the a that we're looking for, because I have no idea what that is yet. That wasn't given to me. And then I'm going to bring in my formula I see up on the top here of the screen. So we go x minus -5, and then we say x minus a 2. Remember, it's always a minus sign there first. Now, again, I would almost be done. As long as I knew what that a was, I would be done with this problem, but we don't. So you know what? We're going to save it for the end. Y is equal to, remember, the negative does become a positive. So I'm just going to say x plus 5 and x minus 2. So notice, I'm going to bring this back. I need to find what that a is. Once I have it, we can plug it in here, and then I'll officially be done with this equation. So in order for us to find the a, so here we go. We're going to find the a. That just means we're going to plug all the other letters I have. We know what y is. It's a 20. So I'm going to write 20 is equal to, no idea what a is, x plus, well, actually, we're plugging in for the x, and our x value is 0. So just a 0 plus 5. We're plugging in the x again, which is 0, minus 2. So 20 is equal to, well, 0 plus 5 is just 5. 0 minus 2 is just a -2. Technically, I'm multiplying all three values here, all three terms, if you want to think of it that way. So 5 times -2 is -10 with an a right next to it. Just have one last step. I need to divide by -10. And once we divide by -10, we get that the a value is just -2. And so just like that, we have found the missing value, -2, and my equation is now officially complete. So that a value, remember, that's what causes vertical stretches, vertical shrinks for our problems. We didn't know what it was until we actually plug everything in to find that one last missing variable, which was the a for us here. So now the question is, all right, we did this with parabolas, and this was in the last unit. So now the question is, well, what do we do when it comes to these polynomials down here? These are not your typical parabolas, right? So these are a little more complicated. So that's why it says, now let's write an equation in intercept form with the given x-intercepts and the y-intercepts on the graphs below, okay? Now, they did give me a y-intercept here. Notice they're skip counting. So my y-intercept looks to be 0, 1. So we have that y-intercept right there. And then when I look at this one, a little more skip counting, but because it's a little difficult to see, notice they did tell us up here anyways. They're saying that's 0, -12. And please understand, it doesn't have to be a y-intercept. It could really be any random point as long as it's on the graph. Just not the x-intercepts. We use that for other stuff. But it really just is any random point anywhere on the graph. We would use it. They're just giving me y-intercepts for this one. Okay, so here we go. Now, just like we did last time, the first thing I want to do is I want to look at this graph and say, all right, well, first of all, what are my x-intercepts? So this is what we've learned before. I'm going to find my x-intercepts first, and I notice that they have one right here at -5, so x equals -5. I have another one here at -1. We have another x-intercept, not y-intercept, x-intercept at 2, and we have one right here at 3. So we have 4 x-intercepts. Okay, so x equals -5, -1, x equals 2, and x equals 3. Next thing I want to look at is, Well, what are my factors? Where did these x-intercepts come from? Right? And when we're talking about factoring, we're talking about let's put these back into parentheses. If we say x is equal to -5, and I want to get a 0 back out of it, well then add the 5 back to the other side, and we get our first factor. This one right here. So this is what I was saying earlier, I just didn't have the space. You can always just come back, add the 1 over so you can get a 0 there. But you see, just like that, we have our second factor right there of x plus 1. So that's what I'm saying. We can always just add it back to the other side. Here, I would subtract the 2 to the other side. That's why my factor that x equals 2 came from was x minus 2. And then my fourth factor here, if it says x equals 3, subtract the 3, so it's x minus 3 again. So we have the 4 factors ready to go. But there is one last thing we mentioned in class the other day, and that's the concept of multiplicity. So that just means I'm going to zoom into the x-intercept, and I'm going to find the behavior for each one of these. So I'm just going to put them in green, and I'm going to put them right into my factors. When I zoom into the -5, notice it follows a linear path, which is why in that case, this is a power of 1. So my multiplicity is 1, giving it a power of 1. But when I look at -1, and I zoom in just to this little part right here, notice how the graph was dropping. It hits the x-axis, and it doesn't go through to the bottom. It bounces right back up. Well, those are one of our bounce back situations. And so the multiplicity for the x plus 1 should be a power of 2. It's a multiplicity of 2. Then I'm going to bring my power of 2 in for this one. And when I look at the rest, let's see. That's not a bounce back. Look at that. That's just a straight line, so it's linear. I zoom into this one, also linear. There's no bounce back on any of those two. Remember, the turn happened after, so no bounce back there. Then these would all be a power of 1. So multiplicity is ready. Well, I'm close to being done with this problem. If you think about it, if I write the equation of this, so far, here's what my equation is looking like, or my function. Okay, what did they ask for? They said, write an equation. Okay, so I'm going to go with classic y equals. So here comes my answer so far. I have x plus 5, x plus 1 with that power of 2 is the only bounce back, x minus 2, and x minus 3. The only issue here is we now have to question the a value, which is what we never worried about before. But we have to be able to find what this a value is. That's why they gave me one more point. Not an x-intercept, they gave me another random point, in this case a y-intercept. Again, it could be any point anywhere. So why did they give me that extra point? Well, they said, we have the point 0, 1. Well, then that just means one thing. There's your x, there's your y. I'm going to use these numbers in my equation. I know it gets crazy with all these extra x's, but I have to find what that a is. That's the only new thing. So here we go. My y value is now 1, is equal to, I have no idea what a is. My x value is 0, so 0 plus 5. I plug in a 0 there. 0 plus 1 squared. 0 minus 2 and 0 minus 3. All right, well, let's see what we have here. A is equal to, 1 is equal to, 1 is equal to, there goes the A. Let's see, this is just a 5. 0 plus 1 is 1, but squared, well, it's still a 1. 0 minus 2, so -2, and -3. Remember, I am multiplying all 5 of these right here together. And when I multiply all 5, remember I'm going to have an a in it, of course. 5 times 1 is 5. 5 times -2 is -10. And -10 times -3. So we have 30, positive 30. And yeah, there's that a, which means I have one more step to take. We don't need that graph anymore. divide by 30, and we just found that our a value, as weird as it looks, is 1 over 30. So I'm ready to come back and write my equation, just like I did earlier. Remember, we kind of paused here. We had to do the work to find the a. So let me come back to where I started from, and here's my equation. Y is equal to, well, it said a, but I already know what a is, 1 over 30, and then I just bring everybody else back. X plus 5, x plus 1 squared, the x minus 2, and the x minus 3. And just like that, we have officially found the equation for this polynomial that hits all these 4 x-intercepts, and it has that 1 point in the graph as well. Remember, it's not always going to be the y-intercept. So we would still just plug in whatever the x is and whatever the y is for that value, or for those values. All right, so very similar to what we did yesterday in the notes, but we're adding one last component, which is we have to find that a value, but we only have to do that if they actually give me an extra point. If no point is given, chances are my a value is an automatic 1, just like they were in the previous notes. All right, last one. Here we go. One more to try. Now, you're going to be doing a classwork, so that's why we're going to do this one together. Yes, they gave me a random point. This is why I know I have to look for an a value, because they gave me that random point. Let's talk about x-intercepts first. Now, these are really close, but I have one at -4. So here come my x-intercepts. X equals -4. And notice right next to it, we have one at -3. So x equals -3. And then we don't have another x-intercept until we get to the number 2. Again, this is not an x-intercept. I don't make it a part of this. Only x-intercepts go here. Those eventually become my factors. So let's see. If it said if my x-intercept is x equals -4, then it must have come from a factor that said x plus 4, because we have to add the 4 back to the other side. If it says x is equal to -3, my factor must have been x plus 3, because I would add the 3 back to the other side. And if it says x is equal to 2, my factor must have been x minus 2, because I would subtract the 2 to bring back that 0. Okay, our factors are done. Now it's all about, like last time, multiplicity. Even though we don't really write much in a line here, when I'm thinking about multiplicity, we're talking about behavior. Look, I know it looks like it's bouncing back. It doesn't. Look at that. It goes just over the x-axis and then comes back down. If I were to zoom in right there, that's not a bounce back. It does go over the x-axis. So that's a power of 1. When I look at this one, notice same thing. It was coming from the top, just barely, and then it went right down to the bottom. This is a power of 1 also. And then over here, when I zoom into this one, look at the multiplicity. There's no bounce back here either. It's going right through it in a very linear form. All of them are powers of 1. So my multiplicity for all of them is 1. Sorry, I should have just put it up here as a power instead. All of them have a power of 1. So I'm ready to start setting up my equation. When I'm setting up my equation for this one, we can start saying, all right, here's my equation. My equation is y equals x plus 4, x plus 3, and x minus 2. Now, the biggest mistake people make on the test is they'll say, cool, I'm done. I finished this problem, but you forget one thing. They gave me this extra random point. Again, it could be anywhere, just not an x-intercept, but it could be anywhere else. But when they give you that random point, it means one thing. There's an a value for you to find. We need to find that a value. And the only point that they gave you so that to help you find that, the point they gave me for this one was 0, -12. Again, it could be any random point. There's the x, there's the y. So of course, we're going to find the a. just like we mentioned earlier. So here's the work for finding the a. It says y, well then I'm going to plug in a negative 12. I have no idea what a is, but I know what x is. X is 0 plus 4, x is 0 plus 3, and x is 0 minus 2. Remember, if you have any issues here with this part, right, ignoring the a, then let Desmos help you out with this. Don't make the little mistakes. So negative 12 is equal to, all right, well, like I said, you can let Desmos handle most of this work for you. You should, might as well. In fact, let's see, we get a 4, a 3, and a negative 2. So negative 12 is equal to negative 24. That's what 4 times 3 times negative 2 is, with an a, of course. And we divide by negative 24. And so just like that, look, we have found what our a value is. Our a value, right? Let Desmos reduce this for you if you need it. Let me move this up here for us. Let Desmos reduce it for you if you need it. Negative 12 over negative 24 becomes a half. So now I'm ready to actually go back up here. Remember, this is where my equation was. It just wasn't quite done because I needed that a value. So I'm going to bring this equation back down here, and now we can actually finish writing it out. We don't need the picture there anymore. So we end up with y is equal to, we already know our a value, so we finally get to bring it in. And now I'm just going to copy the rest of my factors like we had earlier. So x plus 4, x plus 3, and x minus 2. With now our a value. Again, the only time we search for an a value is if they mention that there's another random point that they wanted to give me, then I need to find the a value. In the previous notes, we never gave you an extra point because it was assumed that every a value was a 1. Well, not today. All right, so take your time, copy this carefully. You have 4 problems to try out for today. Again, take your time with it. And if you have any questions, let us know. Have a good day, everybody.